Well, students, we know acid is a substance which gives the hydrogen gas when react with metals like sodium, magnesium, or even aluminium. For example, when sodium added to acetic acid, it liberates hydrogen gas. That means acetic acid is an acid. When sodium added to alcohol, then also there is liberation of hydrogen. When the aluminium is treated with butyl alcohol, that is tertiary butyl alcohol, hydrogen gas liberates. So these two reactions shows that alcohols are acid. Why alcohol behave as acid? This is because of the polar nature of OH bond in the alcohol or OH. OH bond is polar in nature, so when get interact with the metals like sodium or aluminium, that bond breaks and hydrogen gas liberates. So in acidic nature or acidic property, alcohols react with metal, it's a sodium, to liberate H2 gas. For example, ethyl alcohol, C2H5OH, ethanol or ethyl alcohol, react sodium metal Na to liberate hydrogen gas. It is C2H5ONa and H2 gas liberates. So you can show the aroma or you can write gas. Similarly, alcohol, example, it's a tertiary butyl alcohol. Tertiary butyl alcohol react with aluminium to liberate H2 gas. Tertiary butyl alcohol, we know the formula, it's a tertiary carbon COH. Then we can write CH3 thrice. Instead of writing 3CH3 group around this, we can write in condensed form CH3 thrice COH. To get interact with the aluminium A. So it's at high temperature usually when the vapors of the solids pass over aluminium, generally at high temperature. The product formed is CH3 thrice C, then it is O thrice A. This is because we know valency of aluminium is 3. So here is a 3 times 3 CH3CO. 3 times CH3 thrice CO and H2 gas. So 3H2. So here it must be 3 means it is 6. So it is a 6 and it is a thrice means 2 times. Here it is a 2. Both these reactions shows that this alcohol is acid. These two reactions shows that alcohol is an acid. Why is it acid? Because of liberation of hydrogen gas. So acid is a substance which react with the metals like sodium, magnesium and aluminium to liberate hydrogen gas. Well, in this case alcohol, example ethanol or ethyl alcohol react sodium to liberate hydrogen. tertiary butyl alcohol and react with aluminium, liberate hydrogen gas to give the tertiary butyl aluminium reserve. Right? Aluminium tertiary butoxide. Tertiary butoxide. This is the product. Here sodium ethoxide. Sodium ethoxide is the one more product. Well, in these two reactions there is liberation of hydrogen. So you may say these two reactions shows that alcohol is an acid. So why alcohol behaves as an acid? It is due to the polar nature of OH bond. Acidic property of alcohol, acidic property of alcohol is due to polar nature. Polar nature of OH bond of alcohol. Polar nature of OH bond of alcohol. So this point is important. Why it behaves as an acid? Due to polar nature. Well, suppose if you have base, we know base is a substance which can accept the proton. This is a base. ROH, we know it's a general formula for the alcohol. This is alcohol. It's a base. Base accepts the proton. Here it donates a proton. According to Bronsted-Lowry concept, an acid is a substance which donates proton. So ROH donates proton. That means it acts as an acid. This acts as a base. So you are getting the product. This is a BH. You can also write sometimes BH plus also plus OR minus. That means alcohols are Bronsted acid. What is a Bronsted it is? Acid because in this reaction it donates a proton to this base. Well, the base acidic nature of alcohol changes with the type of the group attached to the OH bond. So, if the electron donor group is present, then the acidic character decreases because of decrease in the stability of alkoxide ion. There is a more electron donor group attached to the carbon linked to the OH group, then acidic strength decrease. Why acidic strength decrease? Because the negative charge on the oxygen become more because of electron donation, and the bond between the hydrogen and oxygen is strong. Release of that proton become difficult. When the release is difficult, it become a weak acid. So acidic strength or acidic nature depends on the group of the type of group attached to the carbon of COH. Okay, acidic nature of alcohol decreases. Alcohol decreases if electron donor group is present in this. Electron donor group is present in it. Present in it. It is because, or it is present in it due to decrease in stability. decreasing stability of alkoxide ion. Alkoxide ion. Decreasing stability of alkoxide ion. There is electron donor group, electron releasing group, then the acidic strength decreases because of decreasing stability of alkoxide ion. So example, CH3OH is stronger acid compared to CH3, CH2OH. CH2OH. It is stronger compared to CH3, CH3OH. It is stronger compared to CH3, CH3OH. See here we are only one donor, CH3 group. It is electron donor, it is due to plus psi effect. When there is a electron releasing group, we call that one as a positive inductive effect or plus psi. Due to plus psi effect, alkoxide ion form will become less stable. See here we are bulky plus psi group, that is ethyl C2H5. Here we are two electron donor group CH3, and here we are three electron donor attached to the carbon linked to the OH. So greater the number of electron donor group, lesser is the stability of alkoxide ion formed after the release of proton RH. Alkoxide formed is this one, CH3 thrice CO minus. It is CH3 twice CHO minus. This one is CH3 CH2O minus. This is CH3O minus. So this is the acidic strength of different alcohols. As we know, greater the number of electron donating group, lesser is the stability of alkoxide ion, and it is the increase or decrease in the decreasing order of acidic strength. What about the alkoxide ion order, basic strength? Basic strength of alkoxide ion is reverse. So this is a strong base. Tertiary alkoxide is stronger base compared to secondary, compared to primary, compared to methoxide. Well, here alkoxide ion CH3O minus, then CH3 CH2O minus, then CH3 CH3O minus, then we have CH3 CH3O minus. So this is the increasing order of acidic, this basic strength. That means this is a strong base. Increasing order of acidic, basic strength of alkoxide ion. So from the point of competitive examination, this point is important. In decreasing order of acidic strength is this one. Reverse is that of the basic strength. So basic strength, increasing order, so here is a strong base. Tertiary alkoxide ion strong base compared to secondary, compared to primary, compared to methoxide ion. Remember this point also. It is important from the point of competitive examination like CET or JEE examination. Well, after this, you can compare the acidic strength of water with alcohol. We know the formula for water HOH. HOH. We know the formula for alcohol ROH. The difference between the alcohol and water is, in water there is no electron donor or electron releasing group. We don't have an alkyl group in water. Here we have an alkyl group. As we know, electron releasing group decreases the stability of alkoxide ion and become less stable. So it's electron releasing group, but there is no such electron releasing group in case of water. Therefore, water is stronger acid compared to that of the alcohol. Comparison of acidic strength of water, comparison of acidic strength of water with alcohol. So it is also important which one is stronger acid between the alcohol or ethanol and water. Answer is water. So in case of alcohol, there is electron releasing group and oxygen become more negative. The bond between the oxygen and nitrogen is strong, release of proton become difficult, and alkoxide ion formed is also less stable compared to that of the hydroxide ion. Alkoxide ion is less stable than hydroxide ion. So alkoxide means RO minus, hydroxide means it's OH minus. Therefore H2O is stronger acid than H2O is stronger acid than alcohol. ROH it gives the alkoxide ion, so RO minus and H plus, so OH minus, H2O, OH gives the OH minus and H plus. So this is less stable. Alkoxide ion is less stable compared to that of the hydroxide ion. Stability of alkoxide ion, stability is OH minus is greater than OR minus. So stability, the alkoxide ion or the hydroxide ion, stability, if it is greater, then that become more acidic. So your stability of OH minus is greater compared to OR minus. Therefore H2 is stronger base compared to that of the alcohol. Now it's about the second property, chemical property of alcohol. It's nothing but esterification. So it's a simple reaction. Ester means the compound formed by the reaction of alcohol with the carboxylic acid, and that reaction takes place in presence of concentrated H2SO4. That means alcohol react with carboxylic acid when heated in presence of concentrated H2SO4 to give ester is called esterification. This reaction is also important from the point of examination. What is esterification? Give an example or write general equation for the esterification reaction. Such a question may appear for the examination. Well, next property is esterification. Esterification. Second one is esterification. Reaction of alcohol with carboxylic acid in presence of concentrated H2SO4. To give a ester, is called esterification reaction. Esterification reaction. We know the formula for alcohol ROH. Formula for alcohol. Formula for carboxylic acid R C double bond OH. In both cases we have OH. ROH is alcohol. RCOH is ester. Sorry, this is carboxylic acid. Now there are two possibilities to eliminate H2. Here the elimination of H2 takes place and reaction takes place in presence of H2SO4 after heating. Generally you are heating this mixture. Well, in both cases we have OH. H2 is to eliminate. There are two possibilities to eliminate H2. One is this OH group may non in the elimination of H2 like this. OH, H2 eliminate. Second possibility, this OH group may non in the elimination with the water. So remember, the second reaction takes place. That is, elimination of H2O takes place by the OH group of carboxylic acid and hydrogen of OH of ROH or alcohol. This is very important. Remember, OH group of carboxylic acid and hydrogen of OH group of alcohol involved in the elimination of H2O during esterification reaction. This point is very important. Usually you may get confused which OH group get eliminated, whether from the alcohol or from the carboxylic acid. This is because we know both contains the OH group. Both contain OH group. Elimination of OH from the carboxylic acid takes place. So product is R C double bond O, then it is OR and H2O. So this is the product and this one is called ester. Some of the examples for esterification reactions are examples. Number 1, I am writing carboxylic acid as CH3, C double bond OOH plus we have alcohol CH3OH and we are heating this mixture in presence of concentrated H2SO4. In presence of concentrated H2SO4. Remember, OH of carboxylic acid. This point is important. OH of carboxylic acid involved in elimination as a H2O. Product is CH3, C double bond O, then it is O, CH3 and H2O. Writing the correct formula is important. If there is anything mistake in showing the bond between the atoms, then you may lose the marks in the annual examination. We know this is called acetic acid. Common name is acetic acid. What's the IUPAC name? So total number of carbon atoms are 2. Ethane. What's the suffix for the carboxylic acid? Ic acid. So it becomes ethanoic acid. We know this is called methane, methanol. So acetic acid, it's a methyl alcohol. Methyl alcohol. Product name is, yet name the group which is attached to oxygen. The group which is attached to oxygen is CH3. It's called methyl. This is called acetic acid means acetate. So it's methyl acetate. Methyl acetate. Should be perfect in IUPAC name also. IUPAC name for this one is ethanoic acid. This is because it is difficult to judge which type of question comes for the competitive examination. Ethanoic acid. This is called methanol. Methyl alcohol, methanol. Ethanoic acid, methanol. This one is called methyl. Methyl. We know ester is suffix for ester is O8. So this is the substituent methyl. Then how many carbon we have to 1, 2. So it is ethane, ethanol, 8. O8 is the suffix. So methyl, ethanoate. Methyl, ethanoate is the IUPAC name. IUPAC. So I have to write one more example. Second one is CH3, same thing I am writing, C double bond O, OH, then it is C2H5OH. It can also be written as CH3CH2H, don't get confused here. CH3CH2H or condensed form is C2H5OH in presence of H2SO4. Remember it's a concentrated only H2SO4. Product is CH3, C double bond O, then it is O, C2H5. C2H5 and H2. We know the common name. Common name is acetic acid. It is ethyl alcohol. Acetic acid, ethyl alcohol. So name of this one is ethyl acetate. Ethyl acetate. It is acetic acid. To complete the IUPAC name of this one, means you have to practice this one IUPAC name for this. This is common. It's a common name or driven name. Write the IUPAC name for these two and the product. Third example for esterification is, third example for esterification, you can write at home also. Third example is, it's C6H5COH. Instead of that formula, I am writing the ring structure or benzene ring. It's a Ba or benzoic acid, and it's a C2H5OH, ethyl alcohol, in presence of H2SO4. In presence of H2SO4, product is C6H5COO